Good morning, everyone. I'm Esmeraldine BSED 1E Science. Today, we will having a teaching demonstration. The main objective of this demonstration at the end of the lesson, the pupils must be identify the 4 layers of the earth and to give the importance of the 4 layers of the earth. Before we start our topic, we will have a review. So if you remember, our topic from the last meeting is the atmosphere. It is all about the layers of the atmosphere. Moving on, you were informed that we will be going on a journey to the center of the earth and ask you to prepare these things to bring. First, a map, a flashlight with extra batteries, food and a lot of water, extra cloths that do not burn easily, and extra courage for today's journey. Traveling our way to the center of the earth, let's now bring out our map provided by your teacher. And I will tell first what will we encounter during this journey. First, there is the crust, the mantle, the outer core, and the inner core. Going to our first stop, which is the crust. Crust is the layer of the earth where we can live and survive. This is the Earth's outermost surface and is relatively light and brittle. The crust of the Earth is broken into many pieces called tectonic plates, also called lithospheric plate, a massive irregular-shaped slab of rocks, generally composed of both continental and oceanic lithosphere. And when these plates collide with each other, it is where earthquakes occur. The crust makes up 1% of the Earth, typically about 25 miles thick beneath continents and about 6.5 miles thick beneath oceans. The Earth's crust is like the skin of an apple. It is very thin compared to the other 3 layers. And there are 2 types of crust, and these are the oceanic plate and continental plate. Oceanic plate are plates that are located beneath the ocean and is denser than the continental plate. It is because they are made of denser rocks such as basalt. Second is continental plate. This is a large, solid, and relatively thick tectonic plate that makes up the Earth's continents. These plates can be several hundred kilometers thick and can cover massive areas of the Earth's surface. Moving to our second destination, the mantle. It is composed of silicate minerals and is known for its high temperature and ability to flow light slowly due to convection currents on the Earth's surface. The movement of tectonic plates is related to convection currents in the Earth's mantle. Convection currents. This flow is responsible for the movement of tectonic plates on the Earth's surface. The movement of tectonic plates is related to convection currents in the Earth's mantle. Convection currents describes the rising, spread, and sinking of gas, liquid, or molten materials caused by the application of heat. The mantle is divided into 2, which is the upper mantle and lower mantle. Upper mantle is mostly solid, but its more malleable regions contribute to tectonic activity. 2 parts of upper mantle are often recognized as distinct regions in Earth's interior, the lithosphere and the asthenosphere, while lower mantle is hotter and denser than the upper mantle and transition zone. The lower mantle is much less ductile than the upper mantle and transition zone. It is also known as the D layer. It is defined by seismic velocities as the few hundred kilometers above the core mantle boundary and controls the heat and material flux across the boundaries. And now moving deeper to the core. It is the hottest, densest center of our planet. The ball-shaped core lies beneath the cool, brittle crust and the mostly solid mantle, and is also divided into 2, which are the outer core and inner core. The outer core of the Earth is liquid mix of elements. mostly iron and nickel, with smaller amounts of silicon and oxygen. It goes from a depth of 2,550 kilometers below the surface of the Earth to 4,750 kilometers at the boundary of the inner core, during which time the temperature increases from 4,500 to 500,500 degrees Celsius. The outer core is liquid molten rock, while the inner core of the Earth is solid despite even higher temperatures than the liquid outer core. Pressure is also greater in the inner core than in the outer core due to a greater amount of material pressing down in the inner core. Scientists are able to understand Earth's interior by studying seismic waves. These are waves of energy that travel through Earth, and they move similarly to other types of waves, like sound waves, light waves, and water waves. The movements of the layers lead to natural phenomena such as earthquakes, volcanic activity, and the creation of mountain ranges. Understanding the Earth's outer core and mantle layers plays a crucial role in monitoring volcanoes and predicting earthquakes. For the real-world applications of understanding the Earth's layers in fields like geology, mining, and petroleum exploration, geologists also play an important role in the advancement of alternative energies by studying and searching for minerals to be used in batteries and solar panels, finding and harnessing geothermal, tidal, and hydroelectric power, and more. And this is the end of our discussion. Activities will be provided as assignments, and for the next topic, do a research about biomes and what are their importance. That's all. See you next meeting.